Hello, welcome to ANS Solver. This is the sixth question of the paper. Okay, so as you can see, this is 6 part A. So what I basically need to do is, here I need to integrate this and show that it's equal to ln 48. Now, let's go step by step. The integration of 2 over x, first I know is ln x. Okay, now I have a pre-existing 2, so I'll write that. In the same way, plus I can write ln 2x plus 1 as it is, correct? But there's 2 in the numerator, but now this will be divided by the coefficient of x here, which is 2, correct? So I can write this like this with the limits 1 and 4. So now this can basically be written as 2 ln x plus ln 2x plus 1, correct, with the limits 1 and 4. So what I need to do is, first I need to put 4 in the place of x. So I get 2 ln 4, okay, plus here when I put 4, I get 4 into 2, 8, 8 plus 1 is 9. So ln 9, okay, minus, now I'll put 1 in the place of x. So I get 2 ln 1 plus ln, when I put 1 here in the place of x, I get 2 into 1, 2, and then 2 plus 1 is 3. So this is what I get. Now what I need to know one important log property here, which suggests that b log a is equal to log a raised to b. So using this property, I can basically write this as ln 4 square plus ln 9 minus, I know ln 1 is 0. So it's 0 plus ln 3. So now this can be written basically as ln 4 square, I know is ln 16, okay, plus ln 9 minus ln 3, correct? So now I can use a log property here, which suggests that log a plus log b is equal to log a into b. So using this property, I can basically write this as ln 16 into 9 minus ln 3. Okay, now I can simply do 16 into 9 on the calc. So the value I get here is ln 144 minus ln 3. Now an important log property here again we need to use is simply that log a minus log b is equal to log a over b. So I can simply write this as ln 144 over 3. Now on the calc, I can do 144 over 3 and the answer I get is 48. So my final answer is ln 48, which is what I needed to prove. Okay? Yeah. Now, the B part. This is basically the integration of sine 2x cot x plus 2 cosec x. So now, you need to know some important, obviously you can't solve this directly. It's not possible. What you need to know is some important trig identities. The first trig identity is that sine 2x can be written as 2 sine x cos x. Okay? The next trig property you need to know is that cot x can be written as 1 over tan x, which is simply cos x over sin x. Now I need to know cosec x, which is simply 1 over sin x. So now using these properties, I can write this as 2 sin x cos x multiplied by, okay, cos x over sin x plus 2 in over sin x dx. Now I know if I take 2 sin x cos x inside, the sin x and the sin x here will get cancelled. So I'll get something like, I'll just write it down for you. 2 sin x cos x into cos x over sin x plus 2 sin x cos x into 2 over sin x dx. So now if you see, I can cut sin x here. I can cut sin x here. Okay, so the value I get here is basically 2 into cos x, which is cos square x, plus I can do 2 into 2, which gives me 4, and I have a cos x here, which is cos x dx. Now, another thing we need to know here is that cos square x can never be directly integrated. So you need to know another trigo identity here, which states that cos 2x is equal to 2 cos square x minus 1. So I can write this as cos 2x plus 1 over 2 equals to cos square x, which can be written as cos square x equals to cos 2x over 2 plus 1 over 2. So now what I can simply do is, I can substitute cos square x, the value, in the place of cos square x. So now I get 2 into, basically, cos 2x plus 1 over 2, correct? Plus 4 cos x dx. So I can simply cut 2 and 2 here to get the integration of cos 2x plus 1 plus 4 cos x dx. So now what I simply need to do is, I can write this as the integration of cos, which I know is sine 2x as it is, but this should be divided by 2, which is the coefficient of x, correct? That's how we do it. Plus the integration for 1 is simple, which is x, plus the integration of cos x again, which is sine x. And now because there are no limits, I know a c will be added. So this is basically the final answer of my question.